Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is Muhammad Badris, and on behalf of my group members, I would like to welcome you to our recorded presentation for BTM 454, Technology Management. Today, we will be presenting our group case study report on Tenaga Nasional Berhad or TNB, Malaysia leading utility company and one of the most technology-driven organizations in the country. We will start in an introduction to TNB history and the objective of our study. We will then move into the 4 key technology management practices we observe. After that, we will discuss the major challenges and opportunities TNB faces. We will then connect our finding to two well-known academic theories. And finally, we will share our strategic recommendations and conclude the presentation. Let us begin with the introduction. Tenaga Nasional Berhad has a long and rich history. It was originally established as the Central Electricity Board, or CEB, on the 1st September 1949. Over the decade, it was redesignated to Lembaga Elektrik Negara and eventually privatized in 1990 to become the TNB we know today. The defining turning point in its digital journey came in 2004, when TNB merged its Information Technology and Telecommunications division into a single unified entity. This move allowed the company to modernize its communication networks and better coordinate in digital operations across generation, transmission, and distribution. Today, TNB is no longer just a traditional utility company. It has evolved into a technology-driven organization that leverage smart grid infrastructures, Internet of Things device, cloud computing, artificial intelligence, and platforms like the MyTNB mobile application to serve millions of
Moving
Malaysians.
into technology management practices, I am Norisa and I will cover the first subsection, operational logistics through smart grid and SCADA ADMS platform. The smart grid is at the very backbone of daily power distribution. Unlike traditional one-way power line, the smart grid enables a sophisticated two-way flow of electricity. This is increasingly important as more Malaysians install rooftop solar panel and export renewable energy back to the national grid. The control and automation of this grid managed through SCADA, Supervisory Control and Data Execution, and ADMS, the Advanced Distribution Management System. This platform are operated by TNB Regional Control Center and serve as the central nervous system of the grid. To put the impact into perspective, previously, when a fault occurred like a tree falling on the power line, it would take hours to restore power because a technician had to physically travel to the site, but with ADMS, the system detect, isolate, and reroute the electricity automatically within seconds, completely remotely. And additionally, the TNB has integrated GIS mapping geographic information system to give grid operator full spatial awareness. When a fault is isolated, the exact coordinate is displayed in real-time guiding maintenance crew with full situation awareness.
I am Ali Afika and I will now cover the Service Innovation Truth, the MyTNB, mobile application and the Advanced Metering Infrastructure. The Advanced Metering Infrastructure, or AMI, is the digital backbone behind TNB's smart metering system. In the past, a meter reader had to physically visit every customer's home once a month to record electricity usage. AMI completely replaced this with smart meters that automatically record consumption every 30 minutes and transmit the data securely through radio frequency networks. This eliminates estimation error in billing, allows remote reconnection without a technician, and enable customers who generate solar energy to participate in the net energy metering programs. The MyTNB mobile application is the customer-facing platform that brings all the data to life. It is not just a bill payment tool. Customers can monitor their hourly energy usage, set personal energy budget with threshold alerts, and receive immediate notification about local outage or scheduled maintenance. The app runs on a scalable cloud architecture that can handle millions of concurrent sessions, even during peak billing periods. This demonstrates how service innovation, when built on a strong digital foundation, can transform the relationship between a utility and its customer from a simple transactional one into an active and collaborative partnership.
I am Nur Shakila and now will present on TNB's corporate governance and ICT organizational alignment. TNB operates a highly structured and centralized technology governance environment. At the top of this structure sits the Chief Information Officer or the CIO, who has directly oversight of the entire ICT frameworks. The governance and architecture department is responsible for setting enterprise frameworks, technical deployment principle, and strategic ICT roadmaps. A dedicated governance and architecture department is responsible for setting enterprise frameworks, technical deployment principle, and strategic ICT roadmaps. This department works horizontally alongside sisters department, including the cybersecurity, digital innovation, digital delivery and strategies, and the transformation team. One of the most important governance decisions TNB has made is in its sourcing strategies. Core utility software such as the billing engines, smart grid communication layers, and AMI pipeline is developed exclusively in-house to maintain a full control. Meanwhile, non-critical systems like corporate email and cloud storage are strategically outsourced to external vendors for cost efficiency. Perhaps more importantly, TNB has established a strict technology evaluation checkpoint that every new digital asset must pass before deployment. These gates assess structural compatibility, security alignment, and long-term financial impact, ensuring all digital investment align with TNB's corporate vision.
Assalamualaikum, my name is Muhammad Fatir Fitri bin Nordin and I will present the final technology management practice, performance management through high frequency analytics and digital twins. TNB process enormous amount of data from millions of smart meters and sensor stations across the country. To make sense of all this, TNB use advanced data analytics as the intelligent engine of the grid. Engineering team can monitor live technical metrics including CPU usage, data bandwidth, memories, and API latency, all in a real time. What makes the TNB approach particularly impressive is its use of artificial intelligence and predictive analytics. TNB has built intensive digital twins of its electrical substation. These are virtual replicas that mirror the physical and operational condition of real substation in a simulated environment. These digital twins allow TNB engineers to spot abnormalities, for example, in a high voltage transformer or an underground cable before the equipment fails. This enables planned proactive maintenance rather than emergency repair. The result is a significant reduce in cost and major increase in grid uptime. TNB also established specific key performance indicators or KPIs from system uptime, processing speed, and energy transmission loss. These KPIs are monitored through executive dashboard, giving leadership a real-time view of operational health across the entire organization.
I am Faiz, and I will now cover the challenge and opportunity faced by TNB. Despite its impressive digital capability, TNB faced three critical challenges that cannot be overlooked. First is cybersecurity. TNB manages critical nation information infrastructure, or CNII, and it holds sensitive data for millions of customers. A cyber attack on the smart grid of billing engine could cause a grid collapse or financial data manipulation. The deep integration between IT and OT systems create an even larger attack surface. Second challenge is legacy technical debt. TNB integration of systems like GeoFlora, AMI pipelines, and the MyTNB web portal require complex custom middleware. When customer data between different platforms become desynchronized, it leads to unreliable analytics and poor financial reporting that directly impacting executive decision making. The third and perhaps most human challenge is internal inertia. Engineers who have spent decades performing manual grid operation are often resistant to software automation. This culture resistance requires significant investment in change management, upskill programs, and leadership alignment because even the best technology system is only as effective as the people using it. However, these same challenges open doors to powerful strategic opportunities. The billion of data points generated by smart meters and grid sensors represent an extraordinary strategic asset. When processed to enterprise analytic tools, this data can yield highly valuable insight, not just internally, but commercially. TNB could exchange anonymized data with green energy companies, international consultants, and government bodies like the Energy Commission or Cybersecurity Malaysia, creating entirely new digital revenue streams. Additionally, the continued advancement of machine learning and generative AI give TNB an opportunity to build highly accurate demand forecasting models, optimize renewable energy distribution, and identify grid anomalies before they become problems. An API-first approach would allow TNB to license its own digital tools to third parties. Finally, TNB is uniquely positioned to become the digital backbone of Malaysian smart city ecosystem, integrating with smart transport, waste management, and industrial automation solutions to transform electricity infrastructure into a platform for border nation innovation.
Now, let us connect what we have seen at TNB to academic theory. The first theory we apply is the technology S-curve framework. It's detailed by Joseph Gotcherman in 2022. This model explained that every technology follows S-shape development path, slow performance gain during the initial phase, rapid growth during an adoption phase, and eventually a plateau when the technology reaches its physical or technical limit. We can see all three of these S-curve transition happening at TNB simultaneously. First, manual meter reading has clearly exhausted its curve, so no amount of extra manpower can eliminate estimate billing error or capture real-time data. By adopting AMI, TNB has moved into a new digital S-curve with exponential gain. Second, traditional grid monitoring has plateaued SCADA and ADMS placed TNB firmly on a modernized and growing S-curve. And third, TNB shift from static report to AI-powered digital twin placed at the exciting takeoff phase of data analytic S-curve. Gotcherman also emphasized that managing this transition carries financial risk, especially during early adoption. TNB nationwide rollout of smart meter involved endorsement upfront, investment for delayed return, but strategic planning and thoughtful technology selection can manage this life cycle risk effectively.
The second theory is Everett Rogers' Diffusion of Innovation, published in 2003. Rogers divides any population into 5 adopter segments based on their willingness to adopt the new technology, which is the innovators, early adopters, early majority, late majority, and laggards. When we map this into TNB, we see a fascinating pictures. SCADA and ADMS systems have achieved a full acceptance among the TNB's internal engineering teams, placing them firmly into the early majority. Digital twin technologies and advanced AI model are still being piloted by the internal innovators within the digital innovation and R&D teams, operating in controlled sandbox environment due to their high complexity. For the mighty and application, the picture is mixed. Urban tech literate consumers have embraced it eagerly. They represent the early majority. However, the rural communities and long-tenured traditional consumers and late majority and laggards remain the resistance. To bridge this gap, TNB deploys a targeted multilingual education campaign, community level outreach, and parallel training across the regional station. They turn the senior engineer into the digital champions. Rogers' theory reminds us that technology adoption is a much social process as a technical one, and TNB approach show matured understanding of this.
I am Badris again, and I will close our presentation with our strategic recommendations and conclusion. Based on our analysis, we propose 6 key recommendations for TNB. First, TNB should install a dense IoT sensor network at regional substations to enable a fully dynamic predictive asset replacement program, moving away from reactive schedule-based maintenance. Second, we recommend enhancing the MyTNB app by adding a green energy tracker feature with gamifications elements, such as redeemable points for reducing energy during peak hours and digital carbon badge. This transforms a billing app into a sustainable tool. Third, TNB should integrate advanced cloud analytic platforms, such as SAP Analytic Cloud, with its core utility databases to close the gap between field telemetry and strategic planning. Fourth, TNB must invest in human capital governance. This means establishing digital champions in each regional department, implementing certified data stewardship role, and creating formal ongoing training programs. Fifth, performance management dashboard should be upgraded with predictive capabilities, not just real-time metrics. This allows IT team to anticipate structural issue weeks before critical thresholds are reached. And sixth, TNB should implement a 360-degree feedback loops that combine both quantitative data like API latency and qualitative data feedback from field engineers. Together, this loop safeguard large-scale digital infrastructure over the long term. To conclude, our case study of Tenaga Nasional Berhad offers a compelling real-world view of what technology management look like in practice within a critical national infrastructure organization. The most important takeaway from our study is that true technological maturity is not achieved by quickly adopting separate software systems in isolation. It is achieved through smart integration, evolutionary data-driven progress, and human-centric design across the entire corporate value chain. We learned that data convergence is the key enabler of operational intelligence and that spatial planning tool must evolve with dynamic, predictive decision engines. We also learned that even the most advanced technology will fail if human adoption and behavioral alignment are not actively managed. TNB is well on its way to become not just a power company, but the digital backbone of Malaysia's growing smart city ecosystem. And as future business and technology managers, we believe the lessons we have grown from TNB journey are deeply relevant to any organization navigating digital transformation. On behalf of all six members, thank you so much for watching our presentation. We hope our analysis of Tenaga Nasional Berhad has provided a clear and meaningful insight into the application of technology management principles in a real-world national context. Thank you for our lecturer, Sir Habiel, for guiding us throughout this course. Assalamualaikum warahmatullahi wabarakatuh.